Assalamualaikum and good day everyone. Today, me and Wais will be presenting our video assignment on experiment 12, which is gravimetric analysis on phosphorus in plant food. So, the team members consist of me, myself, Abdul Razik, and also Wais Wafiq. For this experiment, the main objective is to determine the percentage content of phosphorus in plant food through gravimetric analysis. Procedures. Firstly, the plant food sample was obtained and the cell number written on the label was recorded. After that, the plant food sample was weighed around 3 grams using weighing paper and transferred into a 250ml beaker. About 35 ml of distilled water was added to the beaker, and then the mixture was stirred with a glass rod to dissolve the sample. But the sample did not dissolve completely, so a filtration is conducted. To filtrate, 40 ml of 10% magnesium sulfate heptahydrate was added. Then, about 100 ml of 2 mol ammonia was added slowly while stirring. Then, a white precipitate was formed.
Now we seek the solution in room temperature about 10 minutes.
A filter paper was weighed accurately. Then, it was fitted to a Buchner funnel. Then, the paper was wetted with a distilled water. After sitting the solution for 10 minutes, the solution was transferred carefully from the beaker onto the filter paper. The beaker was washed with 2 times of 5 ml portion of distilled water and it was added to the Buchner funnel. The precipitate was rinsed with 2 10 ml portions of 75% isopropyl alcohol through the filter paper.
Okay. After the filtration is complete, take the filter paper and the precipitate and transfer into a evaporated dish.
Now we're going to put it in the oven.
Let's go.
Okay. Now we already put our battery dish in the oven. So we'll wait till tomorrow.
Yes.
Okay, here we go.
1, 2, 3.
Okay, now our solution has been sit in this oven for 24 hours at 60 Celsius. So let's take it out. Let's put it on the analytical balance. So after a while, the mass of magnesium ammonium phosphate hexahydrate is 1.5663 gram. For results and data, the plant food used in this experiment is Bajer Special Green, which states a phosphorus content of 15% on its product label. The mass of the plant food sample used was 3.0915 gram. During the experiment, phosphorus was precipitated as magnesium ammonium phosphate, also known as MgNH4PO4. The recorded masses were: the mass of filter paper plus precipitate is 1.5663 gram. The mass of filter paper alone is 0.7961 gram. The mass of magnesium ammonium phosphate obtained was 0.7702 gram. So now let's jump into the calculation. So for question A, it asks us to use gravimetric factor and mass of MgNH4PO4 to calculate the mole of P, the mole of phosphorus. So we know that molar mass of phosphorus is 30.97 gmol and the molar mass of MgNH4PO4 is 137.29 gmol. So by using the formula of gravimetric factor, take the molar mass of P divided with molar mass of MgNH4PO4 times with mole of precipitate over mole of analyte. So we will get 0.2256. That is our gravimetric factor. So if you want to look for mass of phosphorus, just times the gravimetric factor with mass of MgNH4PO4 and we will get 0.1738 gram. So for the mole, we know that looking for mole, we would divide mass with molecular weight. So 0.1738 gram divided with 30.97 gmol, we will get 5.6119 times 10 to the power of negative 3 mole. That's our mole of phosphorus. So we still at question A, but this time you want us to calculate the mass and the content percentage weight per weight of P2O5 in the sample. So we know that molar mass of P2O5 is 141.94 gmol. So by using the gravimetric factor formula, take the molar mass of P2O5 divided with molar mass of MgNH4PO4 times with the mole of precipitate over mole of analyte. So we will get 0.5169. So for the mass of P2O5, just times the mass of MgNH4PO4 times with the gravimetric factor we just calculated earlier. So we will get 0.3981 gram. So if you want to look for the mole of P2O5, just use the gram we calculated earlier and over it with the molar mass of P2O5. So 0.3981 gram over with 141.94 gmol, we will get 2.8047 times 10 to the power of negative 3 mole.
Now, let's look into the question B. The question states that the phosphorus contained in plant food is usually expressed in terms of P2O5. Calculate the mass and content percentage weight per weight of P2O5 in the sample. Firstly, we need to find the molar mass of P2O5, which is 141.94 gram per mole. Next, the mass of P2O5 is 0.3681, and the mass of sample that we weigh in the experiment is 3.0915. The formula to find the percentage of weight per weight P2O5 is mass P2O5 divided by mass sample times 100%. We put the value into the formula and the answer we get is 12.8.8%. Now, let's look into question C. Compare your result from the amount weight per weight percent state on the label of the plant food. Calculate the percentage error. The formula is percentage error equal to calculated value minus true value over true value and times 100%. As we know, the calculated value on the label is 50% and the true value that we get in this experiment is 12.88%. So we sub the value into the formula and the answer we get is 14.30%. Discussion. The phosphorus content of Baja special grain was determined using gravimetric analysis. The experimental's phosphorus content, expressed as P2O5, was found to be 12.88% weight per weight, which is lower than the value stated on the product label, which is 15% weight per weight. The calculated percentage error was 14.30%, indicating a noticeable deviation between experimental and label values. The discrepancy may be attributed to several experimental errors. Loss of precipitate during filtration or transfer could result in a lower measure mass of MgNH4PO4, leading to a loss of phosphorus content. Incomplete drying of the precipitate or contamination of the sample could affect the accuracy of the mass measurement. Errors during weighting, such as balance sensitivity or environmental factors, may further contribute to the deviation observed. Overall, this experimental limitation can explain why the measured P2O5 content was lower than the value claimed on the product label. Conclusion. The objective of the experiment, which was to determine the percentage content of phosphorus in plant food using gravimetric analysis, was successfully achieved. Although there are some limitations during the experiment, gravimetric analysis proved to be an effective and reliable method for the quantitative determination of phosphorus in plant food.
Thank you.